Hi everyone. In this video we will learn about empirical formulas. Empirical formula is the simplest formula, a formula in the simplest whole number ratio. We have a lot of formulas that we use are technically chemical formulas. They could be empirical or molecular formulas. As you see that, where is my pen? Um, that I have water and hydrogen peroxide, or these are the organic compounds, aluminum chloride, magnesium oxide. These are all chemical formulas. But some of them are already in the simplest ratio, like 2 to 1, and some that I can simplify, like 1 to 1, 1 to 2. This is already 1 to 3. I cannot simplify it anymore. This is already 1 to 1. I cannot simplify it anymore. So those that are the simplest, already simplest ratio, they are in empirical formula. The one that I can simplify, then this is the molecular formula, okay, that tells you the actual ratio. And if I simplify it, it will be H1O1, and this will be the empirical formula. Okay, so the one that I simplify is the empirical formula. This is the molecular formula, the one that shows the actual number of atoms. So empirical formula is the smallest whole number ratio of the elements in a compound. Those that I cannot simplify, I will say that their empirical and molecular formulas are the same. Those I can simplify, then before I simplify it, it is molecular formula, and once I simplify it, it is the empirical formula. All ionic compounds are always empirical formulas, right? So we always take its simplest ratio. The molecular formulas I could I cannot, I could, but I don't. Okay, so like if it is HP2O4, so this is dinitrogen tetroxide, but I do not simplify it. I leave it as it is. But for ionic compounds, we do simplify it. So you have to remember that empirical formula is the simplest formula, and molecular formula is the actual whole number ratio. So let's see that if the question gives you the empirical formula, I mean the molecular formula, all you're doing is to simplify it to get the empirical formula. But if the question does not give you any formulas at all, they give you percentage, then you are supposed to calculate the simplest or smallest ratio, and you're supposed to calculate the empirical formula. So for example, there's a question that the mineral sample is found. You have a compound that has 5.41 grams of iron and 4.64 grams of titanium and this many grams of oxygen. Determine the empirical formula. So my first step is going to be that I'm going to convert my grams into moles. And we just learned in the previous lesson that how we convert grams into moles. So my first step is that I convert grams into moles. So I start with my given 5.41 grams of iron, divide by the molar mass that I get from the periodic table, which is equal to 1 mole. Grams get cancelled. So I get the moles of iron, get the moles of titanium, get the moles of oxygen. Okay, by doing these three, I have the moles of all three of them. Okay, I divided them by the molar mass. So my first step is divide by the molar mass. This is my first step, divide by molar mass to get the moles. Now once I have the moles, my second step is choose the smallest answer here. Well, this is the smaller, these are the smaller numbers compared to this. So I choose the smallest answer, divide by the smallest number of moles. So 0.0969 was the smallest number of moles. So I divide all answers. I have three answers here. I have three answers here. I'm going to divide all my three answers by the smallest number. And this is what I get. I have to have this a whole number. This I need to round this up to get a whole number because this is my empirical formula. So Fe1, Ti1, and O3. I don't really write 1, so this is my empirical formula. That's it. It is that simple. So once again, you are given the grams. You need to divide it by the molar mass, okay, to get the moles. Once you have the moles, choose the smallest answer, okay, divide all answers by that smallest answer. So I'm dividing all my answers by that smallest moles, and this has to be a whole number because that represents the ratio here in the formula. Okay, FeTiO3. So this is how I calculate the empirical formula. If a given percentage composition instead of masses, assume that I have a 100-gram sample. So instead of, if instead of grams, it says percent, instead of grams, it says percent, then I assume that I have 100 grams, and out of 100 grams, I have 36.86 grams of nitrogen and this many grams of oxygen. So I assume that they are in grams, okay? So I again start from 36.86 grams of nitrogen, instead of saying percent, I say grams of nitrogen and grams of oxygen. And the rest of the story is the same. That my first step is that I divide it by the molar mass, okay? Okay, divide by the molar mass from the periodic table, or use dimensional analysis and convert it into moles. And once I have the moles, I choose the smaller number between the two. This is smaller number between the two. So I'm going to divide this by 2.631 and this by 2.631. So I divide both my answers by the smaller number. And it's 1 and this is 1.5. So if I round up, if after rounding I get 1.5, then I need to convert it into a whole number because my formula cannot be in decimals. So I will multiply both with the 2, okay? So that gives me N2O3. So if after rounding I get 1.5, I multiply both by 2, so I get N2O3. So this is the empirical, this is how you calculate empirical formula. To determine the molecular formula, I will be given an empirical formula. I will calculate the empirical formula mass, and I will also be given a molar mass. So molar mass divided by the empirical formula mass equals to N, and then multiply the N with the empirical formula. So this is the formula to calculate it, that you take your empirical formula and multiply it by N. And how do you calculate the N? You will be given a molar mass, divide by the empirical formula mass, and this is how you will do this. Let's do this. This is not a homework. Your classwork, we will do all of this in the class as a classwork, and that's where we will learn this together or practice it together again. There is no homework. It's only classwork. We will do it together in the class and learn or practice how to do this. So that's all on empirical and molecular formulas.